And welcome students. We are continuing our talk about references and class parameters. We are now going to discuss specifically references. So in order to help us explain the concept of references, we will be using the toy class. And of course that can be found in your class notes. This is it right here. And you can see it's a pretty simple program that we're going to be using. We have some private objects here. We have private instance variables. You have one for string name and one for int number. You have some constructors. You have a set method, and you have a toString. You have this mutator method right here, and you also have right here a equals method. Now, variables of a class type name objects of a class differently than how variables of primitive types such as int or char store their values. Every variable, whether it's a primitive or a class type, is implemented as a location in the computer memory. We kind of talked a little bit about that last time. So variables in memory. For a variable of a primitive type, the value of the variable is stored in the memory location assigned to the variable. However, a variable of a class type stores only the memory address of where an object is located. The object named by the variable is stored in some other location memory, and the variable contains only the memory address of where the object is stored. This memory address is called a reference. Variables of a primitive type and variables of a class type are different for a reason. A value of a primitive type, such as int, always require the same amount of memory to store one value. That's because, ints can only be so big. There is a maximum value to the type of int. So the values of int have a limit on the size. Like I said, you can only have so much memory allocated to an int. That's why if you want something really big, but you want it to be like an integer, you can use the long type. However, an object of a class type, such as the object of a class string, might be any size. The memory location for a variable type string is of a fixed size, so it cannot store an arbitrarily long string. So you can't just have this endless volume for a string. It can, however, store the address of any string because there is a limit to the size of the address. So even though the string itself doesn't necessarily have a limited size, yes, it has to be fixed. The memory location of that string is going to be storable. Oops, wrong way. I want to go forward here. Because variables of a class type contain a reference, such as a memory address, two variables may contain the same reference. In such a situation, both variables name the same object. Any change to the object name by one of these variables will produce a change to the object name of the other variables because they're in effect the same object, and we'll look at that here in a second. So let's consider this following code. So here I have toy class variable 1 equals new toy class Joe42. Toy class variable 2 equals variable 1. Now both variables name the same object. Variable 2 dot set Josephine, comma 1. System.println variable 1 invokes the toString method, and then this code would actually output Josephine 1. Even though I did not, with this point, say variable 1, hey, why don't you take the value of Josephine 1? It doesn't work that. Remember, with a primitive object, that wouldn't be the case. It would still say, variable 1 would still say Joe42, but this is not a primitive object, this is a class object. And because you set them equal to each other, they now reference the same memory address. So the object variable 1 has been changed without ever having used really the name variable 1. So let's talk about assignment of variables of a class type. Note that when you use the assignment operator with variables of class type, you are assigning a reference or memory address. So the result of the following is to make variable 1, variable 2 names for the same object. So variable 2 equals variable 1. A variable of a class type stores a memory address, and a variable memory address is a number. However, a variable of a class type cannot be used like a variable of a number type such as int or double. Now this is intentional. The important property of a memory address is that it identifies a memory location. The fact that implementers use numbers rather than letters or string or something else to name memory locations is kind of an accidental property. Now, because we're using numbers, Java is a little smart in this, that it prevents you from using this accidental property to stop from doing things such as obtaining access to restricted memory or otherwise really kind of screwing up the computer. All right, that kind of concludes our notes though for today, folks. Until next time.